Hey, Vet Science, welcome back. We are going to spend some time now talking a little bit about how much air you have in your lungs. And there's a lot of different measurements. It may seem kind of simple, just like, well, wouldn't you just calculate it pretty easily? Well, not exactly. There are different volumes and capacities that we need to learn about. So a volume is always going to be smaller than a capacity. A capacity is multiple volumes summed together. So this is the chart that we're going to be referring to quite a bit over the next couple of slides and in the section of the video. Now, I'm not expecting you to memorize everything on here, but there are a couple of key points that I want you to know. So a volume is the amount of gas that can be stored, but the capacity is the sum of two different volumes, again, meaning that a capacity is always going to be bigger or larger than the volumes. So let's talk about volumes first. Tidal volume, the volume of air that enters and leaves the lungs with each normal breath. So tidal, like kind of like a little wave, like that's a tidal, okay? It's kind of awkward that I'm breathing right now, but for you watching my breathing, but if we were in class, we'd be doing this as well. So expiratory reserve volume is the volume of maximally expired air above and beyond the tidal volume. So in that respirometry technology we just looked at, that's your ERV. You are expiring as much as you can. So okay, like getting out as much air as you can. The residual volume then is the volume of air left in your lungs following a forced expiration. Okay, you can't really calculate that unless you were to take a vacuum into your lungs and figure that out, but we're not going to worry about that here. Just know that residual means what is left over, kind of like residue, okay, residual volume. And inspiratory reserve volume is the volume of additional inspired air above and beyond the tidal volume. So that's inhaling as much as I possibly can. So that amount above and beyond my normal resting tidal volume, okay? Now we're going to talk about capacities. So the capacities, again, are multiple volumes combined together. So a functional residual capacity is the amount of air remaining in the lungs after a quiet expiration. So that's going to be your expiratory reserve volume or residual volume and your residual volume, okay? So that's going to be, let's find it on here, functional residual capacity right in here. Okay, so basically how much air is left in your lungs after a forced breath, and then how much you had in that forced breath. Okay, that's your functional residual capacity. Your inspiratory capacity is the total ability to inspire or inhale. Okay, so that's going to be your tidal volume, so your resting normal volume of air in and out, plus your inspiratory volume. So that's going to be however much you can take in maximally. So that is my inspiratory capacity if I sum together my normal breath and that large inhale, okay? The vital capacity is the measure of the strength of respiration. So that's going to be your residual volume plus your inspiratory reserve volume plus your expiratory reserve volume, okay? So that's going to be the amount of air that you have left in your lungs plus the maximum amount that you can take in plus the maximum amount you can take out. Okay, that is your vital capacity. And lastly, your total lung capacity is all of the air that could be in the lungs at any given moment. So that's going to be your residual volume, your IRV, your ERV, and your tidal volume all summed together. So total lung capacity is always going to be the largest value for you to think about, okay? So some factors that influence vital capacity in general, as your body size increases, your vital capacity also increases, which means that you're able to you take in more breath or more air. Older populations have a lower vital capacity because their lungs start to get a little bit smaller as they shrink. Very young populations have a low vital capacity because they're small little guys. And females tend to have a lower vital capacity as well. Lung volume also tends to be relatively constant fraction of total volume. Lung volume in liters averages about 6% of the total body weight in kilograms, and the resting tidal volume tends to consistently be about 10% of lung volume. So mammals of all sizes have a resting tidal volume of 6 milliliters per kilogram of body weight. So just some important information to know. And I believe that is where we're going to end for today. So thank you for watching. And if you have any questions about the graphs that we looked at today, the volumes versus capacities, or anything about the anatomy of the respiratory system, please feel free to reach out. Thanks for watching.